Welcome back to my channel for the MATLAB activity 21 from your NCERT lab manuals. It is angle in a semicircle is a right angle. Now, what is the objective? We will verify that the angle in a semicircle is a right angle using the vector method. The material required, let's check. The material required is colored sheets, pens, the geometry box, and the adhesive. The method of construction, an easy activity. We just take a sheet of paper, draw a circle with center O and radius 10 centimeters. Once that is drawn, I draw one diameter, and the end of the diameter I mark as point A and B, and I take points P and Q on any one side of the semicircle. So this is the figure that I get. I just draw a circle of radius 10 centimeters. I mark the center O. Once I've done that, I draw a diameter AB. I mark the endpoints as A and B. And I have marked two more points P and Q on one side of the semicircle. Right? Now, after that, from these points A, O, and B, whatever are the possibilities of joining the points, I do that. So from A, I join AP and AQ. From O, I join OP and OQ. From B, I join BP and BQ. Right? Once I have done that, I will mark the arrows showing the direction from the diameter to the points P and Q. So I'll mark the arrows as AP, AQ, then in the direction of OP, OQ, then from B direction, I'll be marking the arrows BP and BQ. Okay. So this is what was done. I've already told you how the arrows are being marked. This is the figure that you'll be drawing in your lab files, the figure number 21. I'll just show you a sample of what one of my students, Unnati, had drawn. So this is what is from her lab file. A circle of radius, how much? 10 centimeters, center O, points A and B on the two ends of the diameter, points P and Q, AP and AQ being joined, OP and OQ being joined, then BP and BQ being joined, and the arrows. Right? Now, using a protractor, I measure the angle between the vectors AP and BP. And I'll find it out. That's going to come out to be APB. Let me just show you how I'm getting that. This angle APB, the angle between the vector AP and BP, will come out to be 90 degrees. The next step is that I'll measure the angle between the vectors AQ and BQ, that is angle AQB. This will also come out to be 90 degrees. As many number of points I take on this side of the semicircle, R, S, T, whatever points, the angle between AR and BR is going to be 90 degrees. That means angle ARB will 90 degree, angle ATB will be 90 degree, angle AST will be 90 degree. If I take as many points I want to take on this semicircle, I will always get the angles between the vectors AX and let's say BX to be as 90 degrees. So this is the next step that we are supposed to do. So I repeat the above process by taking some more points R, S, T on the semicircles, forming vectors AR, BR, AS, BS, AT, BT, etc. Again, the arrowheads have to be there. The arrowheads are all there. And I measure the angles as above. They will not all come out to be 90 degrees. That is, the angle formed between the two vectors in a semicircle is always a right angle. Let us do the observation now. So by actual measurement, I'll measure OP vector, OA vector, OB vector, OQ vector, and they're all equal to what? They're equal to vector R, vector A, vector B, which is equal to how much? Which is equal to 10 units. Then their absolute values. Then I get what? AP. AP vector is how much? I'll measure by using a ruler, and it's going to come out to be 14.14 or 14.1 units. BP vector also comes out to be the same. Both of them, I've taken this as the perpendicular vector. Had I taken it somewhere else, then it would have been a little different. So whatever the length are coming out to be, I'll find out. Let's measure the vector AB. Vector AB is what? It is twice of the radius. That means it's going to come out to be around 20 units. It should come out to be 20 units. AQ vector, if you're going to use a ruler to measure it, it's coming out to be 18.3 units. BQ vector, it is coming out to be 8 units. AP square plus BP square, how much it's going to come out to be? Around 14.14 units, and BP square is equal to around 14.14 units. That is coming out to be around 400 square units. Then similarly, if I'll measure out BQ square and AQ square is 18.33 square and plus 8 square. That also comes out to be 400 square. because it's 20 square. That means it's equal to AB square. So I've got AP square plus PB square is coming out to be AB square. So by the converse of Pythagoras theorem, I get that this angle is going to be 90 degrees. Exactly same way, AQ square plus BQ square is again coming out to be 400 square units, which is equal to again 20 square, which is equal to AB square. So again, by the converse of Pythagoras theorem, I get the result that this angle AQB is equal to 90 degrees. APB is how much? APB is equal to 90 degrees. We all know that. Now let us find out the dot product of AP and BP. Now to do that, I'll just take you to another slide. Dimensions are OA and OB are A units, and OP is how much? OP I can take it to be as P units, right? Now, if I take the vectors, vector OA, if I'm taking OB to be as A, then OA becomes minus A vector, right? The direction, though the magnitude is same as A, but the directions are opposite. So if OB is A, then OA comes out to be minus A. Then OP vector can be represented by small p. Next, what will I have? So AP is what? See, OA plus AP is equal to OP. So I can say that AP will be coming out to be equal to minus OA plus OP, isn't it? That means minus OA means minus of minus A, which is equal to A plus P. And similarly, BP. BP is what? BP is this. BP can be written as P minus A, isn't it? So I can find out both of them like this. Now, if I want to find out the dot product of AP and BP, it is going to be equal to how much? It will be equal to P plus A and the dot product of P minus A. That will come out to be how much? That will come out to be the absolute value of P square minus absolute value of A square. And P and A are what? Aren't P and A equal? The magnitude of P and the magnitude of A both are equal to R. So absolute value of P whole square and absolute value of A whole square is equal to 0, which gives me that the dot product of AP and BP is equal to 0. Now, what is the dot product of A and B? AP and BP, it is equal to AP into BP cos theta, and that means the cos of the angle between them. The angle between AP and BP is how much? It is going to be equal to, because it is the dot product is coming out to be 0, means cos theta is 0. Cos theta is 0 means theta is equal to 90 degrees. Therefore, the angle APB between the vectors AP and BP is the right angle. So this is what I have proved by using the vector also, that it is a right angle. I used the measurement geometrically, I proved. I use the Pythagoras theorem. This side square plus this side square is coming out to be equal to AB square, or AQ square and BQ square, their sum is also coming out to be AB square. So by the converse of Pythagoras theorem, I will prove the whole thing by geometrically I prove, and using the vectors also I have proved that this angle is coming out to be 90 degrees. So similarly, I'll find out that AQ into BQ, the dot product of AQ and BQ, that will also come out to be 0, giving that angle AQB is equal to 90. So let us go back to the observation table. So the dot product of AP and BP, that comes out to be 0. Angle AQB is 90 degree. Dot product of AQ and BP comes out to be 0. Similarly, for points R, S, and T, ARB angle is also 90. ASB angle is 90. ATB is equal to 90. And hence, I can say that angle in a semicircle is a right angle. So let us come to the application now. This activity can be used to explain the concepts of, there are 4 things that we can explain using this activity. Number 1, the opposite vectors. We had A and we had minus A. The vectors of equal magnitude, P and A, they both are having equal magnitude. The perpendicular vectors and the dot product of the 2 vectors. So I hope this activity is very clear to you using this video. In case there's any doubt, you may go ahead and watch it. Don't forget to like my video and subscribe to my channel. Thank you so much.